Welcome to Unit 9, Water Pollution and Prevention. We're going to begin by looking at the first two types of water pollution, chemical and organic waste, after a brief introduction to pollution in general. So, what is water pollution? It's anything biological, chemical, or physical that causes a degradation in the water. It can be problematic due to either its chemical composition or just by abundance. How much of it is there? A watershed is the land area that, due to topography, sheds water into one spot. So surface water follows a slope and then eventually lands in the ultimate body of water. In Shepherdstown, we live in a couple of watersheds. We are in the watershed for the Town Run stream, which runs through town. That flows into the Potomac River. That eventually is a watershed that flows into the Chesapeake Bay by Baltimore. Non-point source pollutants travel with the water. Okay, so what is a point source pollution? Think about anything that has a pipe. If you have a factory that dumps contaminated water into a stream or a river, that would be a point source. A non-point source would be runoff from a farm or city, something like that. That travels with the water through the watershed, eventually landing into the ultimate body of water. Here is the Chesapeake Bay watershed, which I mentioned a minute ago, all the way up into New York and part of Virginia. All of the streams and rivers in this area eventually flow into the Chesapeake Bay. So here is a schematic showing point sources and non-point sources. So our non-point sources are things like agricultural cropland, feedlots, rural homes, a city, a suburban development. Notice no pipe. Compare this to point sources. Here is a wastewater treatment plant with a pipe right into whatever body of water this is. Here is a factory that also has a pipe. Water pollution come in four types, which can be abbreviated COPS. We're going to look at the first two, chemicals and organic waste, which lead to nutrient overload. In this section, the next section allows us to look at pathogens and sediments. Okay, so where are chemical pollutants? Things like inorganic chemicals that might be used to fight fires or from a runoff from a mine. They are heavy metals, lead, cadmium, they're acids, they're road salts. The sources are industry discharges, water treatment facilities, mine drainage, agricultural, roadways. Right. Here is a picture of a mine, the Valley Fill at Lyburn, which is in Logan County, West Virginia, before and after the rain. Look at the sludge in the body of water down here due to the runoff from the Valley Fill. You have organic chemicals, petroleum from spills or leaks from your car, pesticides, detergents. The sources here are industry spills, parking lots, agriculture, landfills, septic tanks. I do not remember what a UST is, but whatever they are, they're leaky. Military grounds would also be a source of organic chemicals. Oh, I bet it's an underground septic tank is a UST. Type 2, organic waste. So we have manures, decaying materials, excess nutrients, sources, again, septic tanks, sewage, sludge, agriculture. They can add a lot of dissolved oxygen to the water. Or they can deplete it because it's used up during the decomposition. Air is roughly 200 1,000 parts per million, 20% oxygen. Water can be as low as 10 parts per million. So we have oxygen demanding waste. So biological oxygen demand, BOD, is the amount of oxygen used by bacteria. If you have a high BOD organism, it has a high organic material decomposition rate, which reduces the oxygen and the organisms in the stream. Sources of this would be farm runoff, which are pictured below, urban sewage, like over here on the left, lawn runoff, natural sources, like the leaves falling in the fall. So now let's think about how fish breathe. As water moves past their gills, microscopic bubbles of oxygen gas in the water, this is the dissolved oxygen, are transferred to their blood via diffusion in the gills. This transfer method is efficient only above certain oxygen concentrations. So when the oxygen gets too low, aquatic life cannot be sustained, and thus all the fish in your body of water die. Okay. 5 milligrams of oxygen per liter or higher is ideal. Less than 5 milligrams of oxygen per liter impairs the life, and less than 2 milligrams leads to hypoxia. Hypoxia is a fancy word for suffocation. We have a dead zone at the Mississippi Delta where it reaches the Gulf of Mexico. This hypoxic area is bigger than New Jersey. In this area, life cannot exist. Right? There is not enough oxygen there to support aquatic life. Water plants come in different types. You have benthic, which are rooted in the bottom, like cattails, bulrushes, weeds, muskgrass, lilies, arrowheads. Some of these are submerged aquatic vegetation, like the pondweeds and the muskgrass. Some are not. There are also phytoplankton, which are single-celled free floaters. They are plants, but they're not rooted to the bottom. Here is a picture of a pond with lots of lily pads. If you have an oligotrophic condition, you have nutrient-limited water. This gives you a bottom-up regulation of your aquatic organism populations. Eutrophic condition, you have nutrient-rich water. Now you no longer have regulation and you get unregulated growth of the aquatic organisms. This is a picture of a eutrophic pond. Look at all this unregulated growth of whatever this particular brown stuff is. Highly technical language there, guys. Right. Eutrophication is a process by which, as you add nutrients, the water rapidly becomes eutrophic, flavoring phytoplankton, leading to algae blooms. So here is a pond with a lovely algae bloom going on. Here is a before and after picture of a pond. This is before. After, the water looks murky because of all of the phytoplankton in it. When you have light, or when you have eutrophication, light at lower levels gets blocked. So an oligotrophic system is what you want. It's low in nutrient, you're limiting the phytoplankton, the water is clear, light penetrates, the SAVs thrive. When you add nutrients, you get a nutrient-rich water, the phytoplankton blooms, the water becomes turbid, and the SAVs are shaded out. And now you've lost all that lovely plant life that you needed to support your fish life, and everything dies except the phytoplankton basically due to suffocation. So here's a question. Is this a eutrophic or oligotrophic system? Sampling reveals high dissolved oxygen, deep light penetration, and low phytoplankton populations. This would be oligotrophic. It has lots of oxygen for our fish to breathe. The light gets all the way to the bottom so that the SAVs can thrive, and the algae, the phytoplankton, is kept under control. Here's another question. We have turbid waters, low dissolved oxygen, low light penetration, with lots of phytoplankton but low overall species diversity. This would be a eutrophic body of water. Nutrient concentrations in streams correlate with land use. In a forested area, I have relatively low phosphorus and nitrogen concentrations. Phosphorus is on the top, nitrogen is on the bottom, notice. As I go from being forest to mostly forest, they go up a little bit. When it goes from being mixed forest to partially town or city, up again a bit more. Urban is more, mostly ag is more, and agriculture specifically is off the charts. Some eutrophication occurs naturally at a very slow pace. However, if it's due to human activities, it happens very rapidly. And one of the things that's to blame is all of our fertilizers. That's what this is trying to tell us. Right? Fertilizing crops, yards, and landscapes leads to cultural eutrophication. Detergents can, piling manure and waste at ag sites. Anytime we add nitrogen or phosphorus to the water, we are leading to eutrophication. Golf course is a good example. So here's something to think about. In your house, you have two types of water produced. You have gray water, which flows from sinks and showers. It does not contain human waste. It does not contain excess phosphorus from cleaning products or toxins, and can be recovered as useful plant fertilizer with minimal treatment. On the other hand, you have black water, which is what comes from your toilet, does have human waste, does have phosphorus from cleaning products and toxins, can be recovered for plant fertilizer, but you have to treat it extensively. Here is a manure pile. Isn't it lovely? Look at the contamination to the water on the surface due to it.